Greetings and welcome, everyone. My name is Nell Arnaud, and I'd like to introduce Keith Gesso and Ken Crawford, who are also two presenters today. We are part of the Health Resource Group, and our zeal is to gather health information from the Future of Mankind contact reports and the FIGU newsletters. Seeing a need for reliable, accurate health information, this enormously valuable health material from Billy and the Pleiarans needs to be more readily available to anyone interested in bettering the quality of their health and lives. Today's presentation is on the immune system. In July of 2022, Billy asked Pata to say something about the immune system. At the end of his 7-page description of the immune system, Pata ended with this statement. To explain this with regard to the immune system is the most important thing that actually every human being should know. We'd like to begin today's presentation with a video of the immune system as it's viewed under a microscope.
Today we're going to take a look at your immune system under the microscope. So what you're seeing on your screen here are a bunch of red blood cells that deliver vital oxygen to our body. The moving cell there is a lymphocyte. That's your immune system. That's what it looks like under the microscope. So its job is to go in between all of these cells in your lymph system and start cleaning up, if you will. What you don't see is that it's swimming in water. That's why we need to drink water when we get sick. What you just saw there is a lymphocyte that's changing direction. That's showing intelligence. It's got a signal called chemotaxis to go clean up a mess, and that's what it is right there, cellular debris. So what you're seeing there is that lymphocyte starting to break down and clean up all that cellular debris. Just like a car that uses gas and there's exhaust, all of our cells use fuel, and then there's byproducts of metabolism. This little stick figure, that is streptococcus. That's your immune system taking care of bacteria. Look how it goes and protects you by enveloping itself around the bacteria. Now this is a picture of natural cell death. This is apoptosis. This is a cell. Just watch the edges of the cells there. It's about to die. And what a lot of people don't know is that our cells are replaced every so often. Red blood cells every 149 days. Other cells may take years, but our cells are replaced with whatever we've been eating at the time. And so it's important to know that these lymphocytes have to go in and clean up all of these cells. And we have trillions of cells. I joke around with my kids and I say, you know, I want you guys to clean your room as well as your lymphocytes clean theirs. And this is what we see. Trillions of cells being cleaned up. And this is why it's so important to eat a healthy diet with real whole foods, because our cells need those big building blocks, not fake foods that are going to break down and add more work to your lymphocytes. When your immune system gets overworked, then it can't protect you as well. What you're seeing here on the screen is natural cell division, and instead of it dividing properly, you'll see at the middle of the screen, it stays conjoined, and it becomes what's called a binucleated cancer cell. Those two dark circles, those are the nuclei. The lymphocytes that are circled there, those are inside the cancer cell, and that arrow points to the cell membrane, and the lymphocyte on the outside is trying to get in. Watch how it pokes multiple times. We count 7 times it pokes to try and get in. If your immune system is weak, it can't get in. If it's strong, it can get in and start to help to defend against the cancer. And so this is why it's so important to really help keep your immune system strong. What wrecks your immune system? Stress. You can see here that it's gotten inside and now it's high-fiving the other lymphocytes. We pull the camera back and we can see that we've now got tissue that's cancerous. Not the size of a tumor yet. This is still under a microscope, but it's tissue. And all those moving things are the lymphocytes. And what you just saw there is implosion from the inside out. This is natural killer cells of your immune system killing cancer, so we put an instant replay on there. This is cancer dying. We now know that to help put our chances of not getting cancer up to the highest, we need to keep our immune system strong. And like I said, what impacts the immune system? Stress. Mental, chemical, and physical stress. When you get sick, what do they tell you to do? Drink lots of water, because those lymphocytes need to be able to swim around and get to where they need to get lots of rest. That way you have less byproducts of metabolism, so there's less work for the lymphocytes to have to clean up, and it allows for your immune system to recover. And then also, what do they say? Take antioxidants, vitamin C, things like that. Why? Because antioxidants is what feeds your immune system. That's what makes them stronger. So in today's world, we need to avoid the chemical stressors like sugar and fake food and add things like fruits and vegetables, organic fruits and vegetables, and supplement them with good antioxidant supplements to keep our immune system strong. I hope you enjoyed this video, and please take care of your immune system.
We'll be revisiting more of this kind of information as we go through. On slide number 2, I just want to point out to you that all of this information is taken from Contact Report 813, which again occurred last July of last year. So Billy says to Ptah, as I know, it is also still the case today that the immune system is largely, not solely, the factor that determines whether the human being falls ill or dies from the epidemic. If you as a doctor can say something about the immune system for once, I am sure it would be instructive for all those who read our talk reports. And Ptah responds, I can gladly do that and say that the immune system of the human being and all those living beings that have it is the factor that largely determines the health of the whole body. But it is not absolutely responsible for providing a complete defense against every infection in full effectiveness. This is because other decisive factors besides the immune system are important for a pathogen to penetrate and cause an infection. This is what we see with COVID. Billy says this all the time, and so does Ptah. Those people who have a strong immune system, these are the people who are walking around. They have COVID. They don't even know it. It's not even phasing them. Their immune system is strong. Those people who really get a strong reaction, you can see that their immune systems are quite compromised. And I believe that they're making reference to that here. The next slide is a lot about what we're dealing with all the time. The body of the human being, as well as of all life forms, is constantly exposed to attacks from environmental influences, parasites, bacteria, viruses, fungi, microbes and toxins, etc., which lurk everywhere. Without the body's own defense system, the majority of all life forms would be defenseless against the attacks of these disease influencers. The immune system, or this is mostly the lymphatic system, where it's part of the immune system, this acts defensively against the attackers and prevents infections, normally rejecting the pathogens that could enter the body from the outside and make it sick. The body's immune system is mainly distributed among the cells and organs, each of which has specific tasks in the complex system and the defense against pathogens. The following can be mentioned: the mucous membranes, the spleen, the bone marrow, the tonsils, the lymph nodes and the lymph node pathways, and the thymus gland. The first is the mucous membranes, and some of these you wouldn't think they're part of the immune system. This is part of your immune system. The mucous membranes are mainly endangered by the penetration of pathogens. For example, the causes of infections, but also the throat, the nose, and the intestines, and ultimately also the skin. If you look at the graphic, it also includes the nose, the mouth, the esophagus, the bronchial tubes, and the gastric mucosa, which is in the stomach, and the intestinal mucosa. All of these things are mucous membranes, have mucous membranes. The spleen, the organ spleen, has to fulfill functions of immune defense, namely with regard to the multiplication of white blood cells, the so-called lymphocytes, whereby overaged red blood cells are also secreted via the spleen. But it also stores defense cells, which are then supplied to the body when an immune defense is necessary. I just want to point out from this graphic, you'll see the two lungs, the two sides of the lungs. And then if you look inside the lungs, you'll see the bronchial tubes. We'll talk about those some more in a minute. Then below that it looks like a bonnet that's surrounding some things there. That's the liver. Underneath the liver is the stomach. And you see it looks like the spleen is spooning next to the stomach. Below that, you'll see the small intestines. And on the border of the small intestines, this is the large intestines or the colon, ascending, transverse, descending, and the part that goes down to the rectum. The bone marrow and the bone cells, this is so important for the production of the white blood cells, but also red blood cells. A few defense cells are also produced as precursors in the bone marrow. The white blood cells are the lymphocytes, monocytes, eosinophils, basophils, neutrophils, while the red blood cells and the platelets are also produced in the bone marrow. The white blood cells, this is all part of the immune system. And as we just saw in the video, the red blood cells, they carry oxygen throughout the body, and the platelets are responsible for the clotting of the blood. You wouldn't think this, but the tonsils are also part of the immune system. The immune system is really complex with all these different body parts coming together, working together. The tonsils also have an initial defense function against the externally invading pathogens. We've all had a sore throat. We've all felt those swollen tonsils and what that feels like. And this is a symptom that pathogens have broken through and they've created an infection. And that's what the healthy tonsils look like. The next is the lymph nodes and the lymph node pathways, which are throughout the body. The lymph node pathways simultaneously form a collection point for defense cells and antibodies. So if you see this looks like a lot of lymph node pathways that carry the lymph fluid throughout the body. So if you notice, if we were looking at the circulatory system, we'd look at the blood and the blood vessels, but we'd also see a heart. The heart is the pump that pumps the blood all over the body. The immune system doesn't have a pump. That's why it's so important to exercise, to make sure that the lymph fluid is moving through the body and it's doing its job. A really great exercise is like a Stairmaster, or walking up and down stairs, or getting on a trampoline. And just, you don't have to jump so high, but you do have to go up and down a bit to make sure. This is a great pumping action for the lymph to flow, to be freely distributed throughout the body. The thymus gland is located above the heart. It is the primary lymphatic organ. The thymus is part of the endocrine system, or a glandular tissue, which is part of the lymphatic system, stores the mature defense cells, or T cells. The T cells, they're born out of stem cells in the bone marrow, and then they migrate all the way up to the thymus gland here. And there they mature. They mature here. And that's where they get their names, T cells, because they mature in the thymus. Okay. Ken, would you like to talk about the primary and the secondary immune system?
Sure thing. So the immune system has two different types of lines of defense against pathogens. Mainly the body's own immune system, which is based on two lines of defense, namely the natural immune system, and secondly, the immune system learned and acquired by the body. The natural immune system, i.e. the adaptive or non-specific immune system, which is inherent and innate to the human being, as to every other life form carrying an immune system. The second specific immune system, has to be learned and trained by the human body, but this requires an initial contact with any pathogens, whereby the body then uses its ability to form antibodies. So there is an early warning system via the skin and mucous membranes. It's given by the so-called branched cells, whose task is to alert a system of early warning of the immune system immediately after the registration of a foreign invader in the body. Protective means of the adaptive immune system are mechanical and chemical barriers. The adaptive or innate immune system is the first to come on the scene as soon as pathogens make themselves felt and seek to find their way into the body. The early warning system usually identifies all foreign bodies and pathogens on first contact. This system, however, is divided into external and internal perceptions, which can be explained as follows. The external protective function is formed by the skin and the mucous membranes, which in their function and existence are also called mechanical barriers, which protect the human body purely mechanically. And this next part is the inner protective function. On the other hand, it's exercised by the chemical barrier. This external barrier consists of body fluids, as well as the body's own chemical substances that prevent the deposition of invading pathogens, such as bacteria and viruses, by immediately directing or flushing them away from the body. The main substances of this chemical barrier are the cilia of the bronchial tubes, but also the intestinal musculature, which, due to their constant movement, are responsible for ensuring that no bacteria or other pathogenic germs can be deposited in the bronchial tubes or in the intestines, the saliva, the eye fluid or tears, the vaginal fluid, the urine, or the gastric juice. So cilia in the bronchial tubes, they keep the lungs clean. Cells on the lining of the airways produce a sticky secretion called mucus. This mucus traps dust, smoke, and other particles in the air you breathe. The cells have tiny hairs called cilia. They sweep mucus up in the airways to the throat, where it is coughed out or exhaled. The other chemical barriers are saliva, eye fluid, vaginal fluid, urine, and gastric juice. Saliva contains the same amount of chemical that's found in tears, lysozyme. If something enters our mouth or eyes, the lysozyme chemicals get to work destroying the pathogen. All right, the next part here, we're talking about phagocytes. The substances that are available to the chemical barrier for the defense or to prevent the invasion of pathogens are the phagocytes and killer cells, which are naturally given. Both types are constantly active in the cellular defense within the scope of their capacity. Consequently, they directly take up pathogens in foreign bodies, destroy them, or transport them away. Phagocytes belong to the leukocytes or white blood cells, which eat up the pathogen, after which what remains of it is transported to the cell structure, where the specific immune system then also carries out the further immune defense assigned to it. Now, the next type of cell is the natural killer cells. They become active in a different sequence, particularly in the case of viruses and tumor-like cells. If they recognize such cell types, then a production immediately occurs to create special cell poisons, which then destroy the viruses or tumor cells. And I will hand it over to Keith to continue.
Thanks, Ken. The second type of immune system is the adaptive immune system. If this specific immune system is explained in more detail, then it is said that it fights specific pathogens in a very targeted manner. It is important to note that if it is to do its job well, it must first get to know the pathogen, which means that identification is necessary. A direct confrontation, so to speak, takes place between the immune system and the pathogen, whereupon after identification, the immune system responds by producing special defense cells that serve to destroy the pathogen. This means that the immune system's reaction takes a little longer because the first contact with the pathogen actually requires clarification as to what kind of invader it is. As is common everywhere, once something has been recognized or experienced, it is also the case with the immune system that on further contact with the same pathogen, it is recognized. Consequently, the system reacts more effectively and immediately takes countermeasures against it. The immune system has learned everything it can about a pathogen through the first attack, then continues to work with the help of two types of cells. The first being the T cells or T lymphocytes, which the human body has in the bone marrow, but which migrate from there to the thymus to mature and are then deposited in the tissue. In their fight against pathogens, the T cells perform three different tasks, namely as T helper cells, which basically initiate the defense reaction in the body, T killer cells, which recognize and destroy infected cells and also tumor cells, T memory cells, which ensure that the specific immune system directly identifies the specific pathogen already infected once on the next contact and can react quickly against it. The second type of cell is the B cells, or B lymphocytes, that are also formed in the bone marrow, and they remain there to mature. Like the T cells, the B cells also have names from the place where they mature. The B cells are always targeted at a particular pathogen, but they only form on that pathogen when the body has contact with it. The B cells are also activated by the T helper cells, and this happens when the pathogen enters the body and matches the B cell. The T cells in turn then sound the alarm, causing the B cells to multiply rapidly and transform into plasma cells, which in turn produce numerous antibodies or immunoglobulins, proteins, within a very short time that render the pathogen harmless. While the innate immune system attacks everything that crosses the body's barriers, the learned immune system is targeted and specialized to specific pathogens. T and or B cells specifically attack a pathogen with specialized targeted antibodies, and do so more effectively even when an initial immune response takes more time because the learned immune system works more slowly than the innate immune system during initial contact with the pathogen. Next is how to strengthen your immune system. Micronutrients take over the key functions for the immune competence, namely in such a way that they supply the body with all the necessary substances or vitamins, minerals, trace elements, and secondary plant substances functions, whereby, for example, vitamin A, or also called carotenoids, vitamin C, vitamin E, vitamin B9, also known as folic acid, vitamin B12, vitamin D, zinc, iron, omega-3 fatty acids, and probiotics. Keep in mind the dosages will vary according to age, weight, strenuous work, physical activity, and health-related conditions. These supplements have a positive effect on the immune system, whereby vitamin D and zinc are of particular importance for the immune system because both are of special importance for the normal function of the immune system. The body is supplied daily with sufficient vitamins, minerals, trace elements, and secondary plant substances, which is usually done through the diet. However, since natural foodstuffs have long since lost their value on Earth due to application of chemicals and other toxins for rapid growth in the entire agricultural economy and also in the private sphere, even before the middle of the last century, since their invigorating naturalness for real nourishment has lost its value in a comprehensive way due to the use of chemicals and other toxins, the assistance of food supplements in the form of additional micronutrients has become necessary and supportive. Overweight or underweight of the human body is in any case and without exception harmful to health because, first of all, overweight increases susceptibility to infections, while underweight, on the other hand, is usually accompanied by a nutrient deficiency as well as a mineral deficiency which negatively affects the immune system. Furthermore, a high-fat diet is to be avoided because this impairs the function of the immune system and thus increases the susceptibility to infections dramatically and uncontrollably. Care should be taken to ensure that sufficient omega-3 fatty acids are always consumed, which are contained in high quantities in fish as well as linseed and rapeseed oil, among others. It is a matter of course in a healthy diet that the diet should be varied and that one main food should not be used repeatedly within 12 days. This is because a diet that is too little varied is completely unable to provide the necessary natural minerals, which impairs the immune system and general health of the body and thus promotes overweight or obesity. If this is adhered to and what is learned is trained by the immune system, thereby strengthening the body's own defenses, only then can it function correctly. In conclusion, I'd like to acknowledge and thank the members of the Health Resource Group for contributing to this effort, to the Carolina FIGU Interest Group for hosting our website on their server, and to the FIGU Arizona Group for hosting this presentation. Please let us know if there are any questions.